All right. So good afternoon, everybody. And what an interesting panel. But now let's move on. And what a pleasure to talk to you today. I hope you're enjoying DVCon Europe as much as I do. My name is Oliver Bell, and I'm working at Intel in Munich. And I'm a member of the DVCon Europe organization team right from the start in 2014, where few of us thought that DVCon in Silicon Valley is a great thing, but why not have a similar show here in Europe? And here we are, already in the 8th edition. And now I have today the great honor to welcome and introduce a very special guest and inspirational keynote speaker, Dr. Petra Frem from Topagoni Product Management. And a little bit about Petra. She has a technical background and she has a PhD in electronic system design. And she started her career as researcher with Cadence Berkeley Labs and spent early years in the automotive industry. She also worked as software stack in a variety of industries, such as pharma, telecom, and cloud tech. All that time, she stayed close to the software architecture and development. When finally a product management opportunity came up at Ericsson in Sweden, Petra went for it and has been in product management since then, really living the product thinking. Today, Petra is a well-recognized thought leader in product management. And more about Petra, she's also one of the 2 hosts at the popular Product Beats show with hundreds of attendees every Tuesday. Product Beats show time is easy to remember. It's 8:27 to 8:57. I hope I remembered that right. And now the title, as you see from Petra's keynote about speed layers, managing the exponential change of technology is such a great fit to DVCon Europe, because as we all have the privilege on working in semiconductor industry, we experience exponential change pretty much every day. And the amazing speed of changes can, in my own experience at least, be sometimes scary, but it's always fascinating to work in an industry which is propelled by Moore's law. And now Petra is taking us with her keynote on an exciting journey. The journey even starts prior to the invention of the microchip, from the horses on the streets to human augmentation. And we will also hear from Petra how to manage the exponential change in technology that we are experiencing. Please join me for giving a warm welcome to Petra, now over from the lovely Munich to Sweden. And thanks, Petra. Warm welcome to this community. The stage is yours.
Thank you, Oliver. What a lovely presentation. Do you all hear me?
Yes, perfect, Petra.
Yeah. And you see me as well, or?
Perfect.
Great. And you remember right, the show is 8:27 Central European time. And this morning we had the show and I was talking about what a great honor it is to be at this conference today. So it's really great we're connecting these events. The Tuesday product events happening around in Europe. Yes, so I'm going to take you guys on a journey today, a speed layer journey. And I'm going to start by, I'm just thinking about the screen, Oliver. Is it possible to remove this?
Yes, I think I pause and you should be taking over.
Yeah, so I don't want to share anything in the beginning. We're going to share a little bit later on, but it would be good to, if you can pause that. Yeah, now it's gone, right?
I hope.
I hope, yeah. Otherwise there would be 2 Petras, and I think that might be 1 too many, actually. Yeah, no more. Thanks, Peter. Peter, maybe. I don't know. I'm really bad at pronunciation. You're going to notice that today because I have a few difficult names in my presentation. Like Peter, okay, like Peter, and I'm Petra then. So Peter and Petra, yes, but let's start. So once upon a time, big city people were really stressed. Everything was accelerating. Suddenly, there were cars on the streets instead of horses. skyscrapers were being erected, and the news, let's talk about the news, because the news were simply exploding. It's not only that the news traveled faster, that you could get news from across the country and across the world in a much faster speed than before. Also, the evening press started to come out. So suddenly you got news twice a day. Before that, it was one time a day. Can you imagine the stress? You don't want to live like 100 years ago. It was seriously stressful. Today, on the other hand, big city people, they are much more relaxed. Not really, right? It's still stressful. And the change we are seeing, especially in technology, it's actually exploding. It's actually exponential. And this was stated already in 2001 by the now famous futurist Ray Kurzweil, another name that I'm struggling with. But Ray Kurzweil, he wrote an article already in 2001 about the law of acceleration returns. So he wrote about the exponential change in technology. And he said that we usually don't see it because it's kind of like you're looking at a circle. If you look at a circle too zoomed in, you'll see it as a straight line. You don't see that it is a circle. So we don't really see the technology, the exponential change in technology, because we experience too short a time. But if you zoom out a little bit, it's really there. And it's going to be something like the 21st century. We won't experience 100 years of tech change. We're going to experience more like a 20,000 years of experience in tech change in the same rate as we're going about today. So that is, massive. So possibly we can't even say or predict what the future is going to look like because we can't even imagine all the changes that are going to take place. And we can, let's take some examples of things just to start thinking about it, like virtual assistants, for example. Those are that trend is going to continue. We can be sure of that. And also, they even have a sense of humor nowadays, right? So if you ask Siri, for example, what shall I wear for Halloween? She will answer you, go as you are, pumpkin. Or is it just me who get that kind of answers? And then we have human augmentation, right? Like cyborgs, that actually, if you lose a limb, it's even possible with organs as well. You can replace them with a robotic arm then. And you can still control it with your brain. So that's kind of amazing, the advances that have happened in that area. We also have things like 3D printing, which feels kind of old now. We already have that, but it's going to move even further in the future where you can combine different materials. So you don't have to print everything in the same material. It's already happening, I know. So that will, of course, have impact on logistics, for example, and things like that. And we're going to have a computer telepathy. I don't know if you heard about this, but in 2019, there were 6 scientists from Washington State University who interconnected 3 players, 3 humans, their brains playing Tetris, and they did it completely by brain power. So already now we can do that. So imagine what is it going to be like 2045, for example. And I can't resist this, I'm sorry. But now that I have, the brain trust of the design and verification conference here, I just have to ask you guys, what do you see in the horizon? If we talk tech, what do you see in the horizon? What's happening? What do you hear about? What do you think? 2045, what do you think? So please write in the chat what your thoughts are on the exponential tech change that we are experiencing right now. See if we have anything that we haven't already mentioned, maybe something new that no one has heard of yet. We might be living in March. Yeah, we might be. Might not only be a midlife crisis as we hear sometimes. It might actually be for real. Cars Will Fly is really, really interesting because yesterday they had a rerun of The Fifth Element. I don't know if you watched this movie with Bruce Willis as the hero, right? And they have flying cars and they have their interstates in several layers. So yeah, maybe cars will fly. Holodeck, yes. Yes, actually I had holograms on my list as well. I didn't mention it though, because hologram is also a technology that has been around for quite some years, right? But it's also taking off now in recent years and being much more interactive and much more capable than it used to be. Dystopia, that's kind of depressing, right? Transistors. Aha! Interesting. So no more transistors in 2045. Power efficiency, I also think it's really interesting. But what's going to happen in the power industry? The batteries has been lagging for years, and now they're picking up. So what's going to happen in this area? It's going to be I think it's super hot, right? Chips in the body, yes, like in the Matrix. Definitely, I think. And actually, I already met. I was on I don't remember where I was, because the only thing I remember is that I met this person there who already had a chip in his hand, which actually was access controlled to their company building. So they already used that. It was for the vending machines, it was for the doors, and for other things. It was voluntarily still. So if you didn't want to have the chip in your hand, you could get an access card, you know, the old-fashioned way. But he had a chip in his hand. Great. Okay, so let's move on. Let's look at something else. Okay, so we have talked about the exponential change in tech and things going faster. So let's talk about a little bit about things that are not going faster, where we actually are maybe even slower today than we used to be. And I know for those, if there are any like English people here, you know, Top Gear, they always talk about Concorde, right? The airplane, that actually it takes longer now to travel London, New York than it used to do. So that's one thing. But if we move away from that obvious one, there are also other things like skyscrapers, for example. It actually takes longer time to build a skyscraper in New York City today than it did 100 years ago. So the Empire State Building that was built like 1930, it took 13 months to build the Empire State Building. And One World Trade Center, which was built just now 10 years ago, it took 7 years to complete, 7 years. And of course, part of it is like regulation and safety and work. You know, we are regulating the work environment a lot harder. Lots of good things. But there are also things like logistics again. So it actually takes a lot more time and effort and planning to get the material needed for a skyscraper into New York City today than it did 100 years ago, which kind of makes sense if you think about it, because we have built more. So there are more, the context is more complex. You know, you have Wi-Fi, you have all the subways, you have electricity, you have water, you have all these pipes, and you have just the traffic, you know, just of getting the material in takes longer today. So we are building like a more complex world, which is also slowing us down in many ways. Another great example is, of course, standardization, which is something that impacts us a lot. And standardization is great, right? It opens up markets. It makes it possible to integrate technology in new ways. And all in all, it's a huge advantage with standardization. But it slows us down. It will take longer, because then we have to agree, we have a committee, we will do review, we will, you know, iterate things, and then we're going to have to implement and apply to this, adhere to this standard, etc. And one really great example here is Dolby Audio, that I'm going to talk a little bit more about later in the presentation. They actually work, if you talk about Dolby Audio, and they work in the audio space, obviously, and they are very much depending on encoding, decoding algorithms. They have some awesome, smashing algorithms when it comes to sound experience that they are basing on brain research, which also takes time, of course. For example, they have this spatial audio that you can actually sit in a shitty conference call and still hear where people sit in the room when they talk. And that's actually, they're actually messing with your brain on that one. But still, you know, they are depending to get these kind of big changes into their technology. They need to wait for the new standard, for a new standard to come around, because that's the opportunity when they're updating all the tech. This happens every 8th year. So every 8th year, then there is an opportunity for this kind of leap in technology in that industry because of standardization. And then we have, healthcare industry, where you have this tons of data. You have millions of records with all this hidden gold in them, right? With all the, for example, during the pandemic here, you really wanted to run all of this to find the patterns and where you have these breakouts, etc. And you needed to do all the privacy bit first to anonymize the data, and then when you cross-reference and etc. And all of this data processing is just not doable with traditional processing mechanisms. So you're going to have to level up on actually how you're processing the data now that we have so much data. So there are things out there that will slow us down, but there are also many things that will speed us up. So how can we, balance these two forces? So if we look at one of the most complex systems that we have, and I don't know, maybe you're going to be surprised now when I say this, and this is a system that not a single person can understand, and it is actually the financial system, right? The world's financial system. How is this all connected? How can a mortgage crisis in the US actually make Sweden almost go bankrupt? Everything is connected. And this is a extremely complex system. And still though, nowadays, I will show you, I have my bank in an app. And I even have like my retirement savings and stuff just in an app on my phone. Isn't that cool? And when I grew up in Sweden, it was even like this, that the banks, they closed at 3 p.m. in the afternoon. We even had a song about that, what do they do in the banks after 3 o'clock? Nobody knew, unless you worked at a bank, then you knew. But now my bank is open 24/7, right? Because I have it in my pocket. So how is that possible? So they have been working with something that Gartner calls bimodal IT, which actually is that they are layering these or pulling these apart, right? So you have the complex system, you have the back end, you have all the integration points and everything, and that is in one speed, and it's very conservative. Thank you, I appreciate that. I don't want an experimentation on my retirement savings, right? And it's like conservative, slow, it takes time, it's complex. And then they have the front end, the app in my phone and some other features, etc. Like, for example, they want to be able, if you call them, they want to be able to guess what you're going to ask before they pick up the phone, which is kind of scary, but that's also things that they're working on. These things are moving much faster. So they have a much quicker pace where they can release much faster, and they can do A/B testing on their apps they have in the mobile phones, etc. So when we talk about it like this, it's some kind of stupid, like, yeah, of course we have that. But when it came around, when it really happened, this transformation, for those of us who remember it, who are old, this was major, right? Suddenly we wanted to open our IT system for the end customer. It used to be a person working at the company always interacting with the IT system, right? If you bought a train ticket, you bought it from a person who worked for a train company, actually interacting with the system. If you were going to the bank and doing a bank errand, it was a bank person who did it, interacted with the system. And suddenly I, as an end customer, is interacting with the system, right? So that's kind of a revolution happening. And this revolution and many others, which are happening because the tech is just exploding, and we need to do things a lot much faster in some of the layers. We have developed a framework for that here at Tolpagorni. A framework that we call speed layers. And we are claiming that this is the secret sauce to effective product management, or to successful product management. It is sort of a philosophical framework, a way of thinking, something that will help you. So you're actually taking in the time perspective, or the pulse, the beat, the rhythm that you have, that your product or your technology is existing in. You take that into consideration when you're thinking about your product. And this is based on a lot of research. There is a lot of research out there in the field. And I'm going to say, get one example here for you guys. Speed, rhythm, and time space. by Nick Pryor. This is one of my absolute favorite papers of all times. He's actually written a whole paper about museums. So if you ever get tired on the system on ship industry, you can move over to museums. Lots of exciting research happening there. And he's talking about these different speeds that museums, or rhythms that museums are interacting in or living in, or that they have to relate to, you could also say. So it's really fascinating. And there are, of course, like we can also see that there are development frameworks today, like Agile or scaled Agile and things like that. They're also talking about different speeds that you have in your development, that you have kind of value streams that have a bit longer horizons, and you have your daily releases at the bottom where have a much faster pace, etc. So the time perspective is there in a lot of different research frameworks, models. And we have kind of put it all together into a model. And it's also based on a lot of experience from many companies that we are working with. And I'm going to give you a little bit of introduction to the speed layer. And then we're going to do some think a little bit about it. And you're going to go do a Mentimeter and see where you will place yourself and your daily work. And then I'm going to do a little bit of a deep dive into the layers in different parts in the speed layer framework. And finally, I'm going to give you examples from where we have implemented this way of thinking. Okay. So we're going to start with a brief introduction. So you know that I also work as a teacher, right? You can almost sense that because I'm like, so now I'm going to give you a brief introduction to the speed layer framework. And while I do that, I want you to start thinking about your own work, because that's going to be the next question. So speed layers. We generally say that there are 3 speed layers, 3 different times or pulses or beats that your product exists in. There could be 2, there could be 4. We have been around doing this at a number of companies. We have never seen 4, actually. We have seen 2, but mostly 3. But we're not saying that there can never be 4. But for now, I'm gonna present 3. So we have speed layer 1, which is the fast layer, the need for speed, where we need to be really, really fast. It could be things we're testing, prototyping, experiments, A and B testing, you know, you name it. It could also be customization, support tickets, things you need to answer, that you need to be quick in answering. It could be sales calls, you know. And then we have the layer 2, keep the edge. This is if you work in product management, if you're a product person, this is your layer, you know, product. All products have a certain beat, and that beat is depending on the market you're active in, right? So in some markets, you're supposed to release a new product or a new product release every month. In some, it's like every 5th year. And for Dolby, then in that case, you know, they do the new technology shift every 8th year, but they actually did the product release twice a year. And here it's like in this one, you have your edge. So this one is going to be copied. You're going to have to live with that, right? Move on, keep it up. You're going to have to move. But then the bottom, the foundation, the layer is the core. This, if you read Michael McGrath and his defining technology, this is where you will find the defining the technology. This is like the platform for you guys. This is where you build possibility to be sustainable and to be successful, continue to be successful, to actually deliver many products on top of your technology, for example. So this is usually where you have your technology, for example, where you have IP, where you have research, where you have the little bit the layers that are the things that are allowed to take a little bit longer, when it's better to think a little bit more. Yeah, so we are now going to take a Mentimeter where I want you, so we're going to share a Mentimeter where I want you guys, it's going to be 2 questions. The first one is going to be about which of these 3 speed layers then do you spend most of your working hours in? And then the second one is going to be what kind of pulse or beat do you have in that layer? What's the driver and how often is it? Is it like every month? Is it every, second year? Or is it every fifth year? Or is it depending on acceptance tests or on support tickets or market evolution, or what is it? Yes, so I hope you all see the Mentimeter now on your screens. You'll just log in and there is a code. You can do it on your cell phone or on your computer. Yeah, we see people starting to answer. Great. The edge, good. The product layer. Great. We're gonna wait a bit. Everyone is not so fast, maybe. It's exciting to see. I don't know. I thought I had this assumption that you guys were gonna be in layer 3. That was like a prejudice of me. Now we have a tie between the edge and the core. Oh, now the edge is edging ahead. You say that? Edging ahead? No, I don't think so. I'm kind of inventing my own words here as well. But we don't have that many in exploration, not that many fast-moving people out there. Oh, okay, good comment in the chat here. Most people would like to be in layer 3, but maybe are forced to work in a different layer. Could be very true, actually, yes. And these kind of layers thinking, you can also use them for like business case when you talk about money, that usually in layer 3, for example, we talk about investments. It's your ticket to compete. Maybe you will never have a return of investment of those, but if you don't invest there, you will never be able to enter that market at all or build that technology at all. And then for, the product layer, there are business cases, obviously. But you can also use these layers for kind of like a quality thinking. Like we talked about the bimodal IT, that in this layer 3, the core, you can never, ever allow your core to be corrupt. You need to have high quality here. It needs to be scalable, robust, to be able to move on, to build on top of. So your fast layer, for example, can never corrupt your slower layers. Then you have a problem. But up here in the layer 1, even in layer 2, depending on your industry, you could allow for a little bit, good enough quality then, for example. Yeah, edging ahead is just fine. Thank you. You can say that. Good, let's move to the next question. Now I would like to, the layer that you answered, for the layer that you answered that you spend most of the time in, could you think about what is the driver in this one? What is it that sets the pulse of this one? So what is the pulse? It's 3 years, 2 years, 1 year, 2 months, 1 week, 1 day, and what's setting it? Is it like answering times on your support tickets? Is it acceptance test? Is it IP, or what is it that's driving your pulse? Just to have a feeling, and this is free text, so you just write your text, just to have a little bit of a feeling what it's like where you sit. Now we have something, 2 years, and also write what it is that's driving it. So 2 years, but what is it that drives these 2 years? Is it you have product release every second year? Monthly deadlines, yes. Customer support's a great driver, because usually you have a turnaround on these, or you have SLAs maybe or something. Customer application, yearly plan. 5 years we have here. Product releases. I work on multiple products, just right. Every other year, market competition. 2 years and it's market competition. That's very clear. Good. quarterly, new process notes, methodology, which is always behind the edge, 1 to 2 years, yeah. 4 to 6 months, schedule of the LHC, competition, yeah. A lot of you guys are driven by competition, which is not bad, you know, and then you think about yourself, you are the competition for someone else, right? So you're setting their beat. We have new requirement. The core moves once per 2 or 3 years. You all have rather short. 5 years is the longest I've seen here. So not really, it's not like if you're building a new engine for a truck, it takes like 25 years or something. Yearly deadlines. What is your pulse? Yeah, deadlines keep happening. I love that. Yeah, great. Okay, so let's look a little bit on the layers, just a little bit more, and then we're going to do some examples, and then we're going to have a Q&A as well at the end. So please feel free to ask questions as well. Okay, so if we look a little bit, if we're talking about the guide, we have some guidelines here for the explorations layer. This is the fast layer then. If you want to be fast, you know, what do you need to think about? First of all, forget about reuse, right? Reuse is never going to be fast. So forget about reuse. Also forget a bit about, you know, other things that slows us down is this corporations, right? If we want to have like a customer journey flowing perfectly fine, etc., all of that is slowing us down. So it's great if you actually can work in a silo, you will be a lot faster. It's going to come with other costs, obviously. But if you want to be fast, that's the way to go. An end-to-end fast team that could deliver it. So it needs to be encapsulated, for example, because you can never allow this layer, if you have customization, etc., to corrupt the other layers, because this is where you take shortcuts, right? No reuse, fast feedback loop, you know, and a few things like that. And it might be good to say, so put up some, if you want to work with this kind of thing, that you want to have a really, really fast layer, it might be good to put up some logic for it so that you don't steal resources from other layers. Like some of them are, you already complained in the chat, right? I would like to work in layer 3, but I'm constantly maybe pulled into other layers. So there needs to be some sort of balance in here and thinking about that. Okay, let's look at the next layer, the edge layer. So the edge layer, this is where you differentiate. So this is where you're going to have your differentiation. What makes you unique? Why should I buy your product? Why is your technology cooler? So this means that you're going to have to exchange this continually. This will be copied and you're going to be just like have you worked with the Kano model for prioritization? You know, where you can have these awesome features and they're great and they're stunning. Like the central locking of the car was great when it came and now it's standard. If your car doesn't have that, you know, what kind of car is it? Is it a veteran car? Or so, you know, these kind of cool things, they will be moved into basic things. It's almost like a law of the nature. This is also, if you work in product, this is also what you're going to marketing. So it's good if you can clearly demonstrate the value of this one. Great. So the final, the core, your defining technology, the shit, if we talk open language here, this is your secret. This is what's impossible to copy, or at least very hard to copy. It doesn't have to be a technology or a platform. It could be a process, for example. You could have the best manufacture process there is, for example. So you can do it much cheaper or much more tailored, for example, than other companies can do. Then that process is actually your core and your well-guarded secret, and where you don't want to play around with that one. You want to be conservative here. This is your secret, you know, to success. And yeah, this is your ticket to compete. This is where you have your knowledge, your IPR. And if you work at a company like Tolpagorni, for example, like I do, or Product Beats, you know, our core is knowledge. We are a knowledge company. takes time to build knowledge. It means that we always have to do this. We have to, read books. We have to be out there, meet companies, understand what they do, what's happening, what's the challenges, etc. It's the same if you're in research, right? Then this is your core, and it takes time. Okay. Let's do 2 examples where we have implemented speed layers. We have a lot more examples, but I've shown these 2. One, because it's a reference case, so we always show that. And then a smaller one just to box a little bit one of the things that you might achieve with speed layers. So our reference case is Dolby, that I already mentioned, Dolby Audio to be exact. And Dolby Audio, they have a crazy ecosystem because if you want to have Dolby enabled sound, you have to use Dolby technology in the entire chain, all the way, from where the sound is actually created on the movie set or in the processing tools there, all the way through the different broadcasting units, etc., what it is, all the way until you're consuming it in your TV or with your phone or whatever it is you're consuming it, the sound. All of these have to have Dolby. So it's a huge ecosystem, crazy ecosystem if you think about it actually. And they only sell to at the very end of this tail. They sell to the TV manufacturers, for example, but they have to be in all the places in the ecosystem. So when we did this at their place, it was very obviously that they needed an outside-in perspective. They needed to look at the pulses outside that are, their reality. And they have, as I already said, they had this very slow pulse, which is the standardization cycle, which is 8 years. So down here, they have 8 years. They have an 8-year cycle. So it's very slow. And they know they have to work on this all the time, though, because they're also part of writing the specifications and standards or influencing them and then implementing them and taking new IPs, etc. on them. And then they had this product layer, which is when the TV manufacturing are releasing new software or releasing new hardware. And that's twice a year. So that pulse was also very, very, very clear. Twice a year, there is a new product release. And these are minor changes, evolution, where they correct things, etc. Nothing major. The major are every 8th year. And then twice a year, they have this. And then on the top, they didn't have this top at all when we came in and we did this analysis. They didn't have any possibility to do anything fast. So anytime that someone called them and wanted them to come to a show or they wanted to go to BBC and test a new concept, etc., they had to do a product release. So they had to go down here and do a product release for that specific purpose. So they introduced this fast layer to be able to do those kind of things, to work close with customers, testing new things, and also to demonstrate things at fairs, etc., that weren't completely developed. And they did it in a very structured way. They actually created an infrastructure team that were consistent, and then different players were participating into that infrastructure team, depending on what they needed. Because when they were testing something, they needed kind of a big equipment with all the hardware, etc., for testing it as well. So they actually split their fast layer in 2 layers, you could say. One slow, consistent layer with the infrastructure and the test equipment and software, and then a faster layer where you're actually participating depending on what needed to be tested. So that was a neat way, enabled them to do a lot of things faster. They also had another big revelation when they did this, what was the ecosystems, that they work with rather complex ecosystem. And when they're establishing a new ecosystem, they do that every 8th year, for example, and that takes a lot of time and a lot of efforts. And then they need to keep this ecosystem healthy with the same pulse as they are releasing new things. So when they do their minor releases, they have to make sure it works across the whole ecosystem. And then in the very fast layer, they could test new ecosystems. So for example, when they were going into the mobile phones, they did that as a trial, a test on the fast layer first. So that was one example of speed layers, how you could do it. And then we did it another way in an automotive company. That's not a reference case, so I don't have a name here. I only have automotive, and it's not a very, this picture doesn't say so much maybe. But when we were at this automotive company and looked at and this is also kind of a classic one, they had all their data were, you know, inside, embedded into other parts of their systems. So the really big thing here was really to extract all of that data out, to make clear APIs, let the data live its own life, because the data part of the product needed to be a lot faster. It needed to change a lot faster, because this area is still a rather new and changing area. If you talk analytics, if we talk AI, intelligence, and all of those things, it's still moving pretty fast. So it's good if you can, you know, enable the data or extracting the data so that can move faster, because right now a lot of things are happening there. So that was kind of the main takeaway from that case that we did, that this here you need to be fast. So let's make very clear interfaces here so you can extract this out. And then they had a product part, which was actually different car brands that they were managing. And then they had a platform, which was, you know, had been around for quite some time. And the next generation of this platform was going to be the cloud. But that's a different story, right? That's a topic of its own, the cloud journey, which a lot of us have done now. So see what the next journey will be. Okay, so that was my presentation, and now it's time for Q&A. I don't know, Oliver, if you're gonna moderate the Q&A, or maybe there are no questions. Everything was so cleared.
Oh, let's see what's coming in. So I think it's both possible. First, put in a question on the chat or ask it directly. In that case, please raise your hand. So let me start with one question, Petra,
yes.
Which is how much you have exposure now on the semiconductor industry recently, because as we have seen, so much changes are happening in that industry, and nobody really put more than 5 years in your question, in your Mentimeter.
No, I was actually surprised that it was only 5 years in the Mentimeter. Any reflections on that from someone else? Or maybe from you, Oliver, why it's not longer time?
Yes. As we are driven by such exponential changes, you know, our industry driven by Moore's law, then it's several generations in the time, which means this drive is so fast, so exponential. I cannot really tell what, you know, we asked about what is in two years, but I cannot really tell what's in the next 3 months. Of course, I have the planning, but I'm sure there will be surprises which I have not thought about it. So let me see, any questions on
We have
chat?
a question from Jacob, I guess. How do you transition something that works from exploration to edge? Yes, that is a very good question. And actually, I haven't talked at all about this, Jacob, but you're spot on the toughest part. And that's true for anything that you do, that the magic is always in between the boxes, right? The logic between, like, how do we communicate between? Okay, we have created this this layer where we're really, really fast, but we have learned something here, and now we want to use it in the product layer or in the edge layer. And then actually, my preferred way of doing this, and I know some managers are gonna be very upset now, is that you do it from scratch. That you see what you have done, that what you have done in layer one, what you have learned, it's almost like a wireframe or a prototype or something that you will take with you as an input when you do the product development or the edge development and that kind of. But that development that you do there, it has to be, you have to be able to support it, maintain it, scale it, all of those things. So it's not going to be one-to-one. because if you have to take all these consideration when you do the layer 1, you will be slow. But that means you're going to have to redo it when you move down into layer 2, to the edge layer. So that is kind of the hard part. But then how to actually catch these, that we have learned something really good here. That's the same as, this is the same problem we always have. How do we communicate across a big organization or a big company or a product development team? It doesn't even have to be big. But you have to have that feedback loop. It's really important. That's actually one of the guidelines, because otherwise it's a bit waste if you don't learn anything and take it into your real product development. Product programs center around 3 to 5 years for major updates. Yeah, okay, so that seems reasonable. 3 to 5 years. Still a pretty fast-moving industry, I would say. I'm around in other industries that are a lot slower.
Actually, that's another question then. How you anticipate the changes for slower moving industries, where also the planning had to be done 5-10 years ahead? How is this working, Petra?
I think that's a really good question, Oliver. And I think, for a lot of so we see this kind of frustration, you could say, in some of the slower moving industries. And a lot of them are about actually a lot of them is in your home areas, right? In verification and acceptance test, and like how often can we even deploy to our customers, how often can they even take a software upgrade from us? So we actually done this speed layers, for example, in a company that are in the defense industry, and they are extremely conservative. And they have long cycles. They also have like 8-9 years. They sign a contract, they deliver the product 8 years later, for example. And then a lot of things has changed in between. But they are kind of locked in this. The big challenge for them are in this verification phase. So this is the specification. Now we're going to verify and run our acceptance test on this one. So here you have to be innovative, right? And there has to be tech driving this, I think. And I've seen in another industry, in telco, where they, in a traffic management system, where they actually automated this entire acceptance test process. So they used to take them a bit over a year to run through all the test cycles with their customers. And now they can do it in 1 month. So I think actually, you're in the right spot. It's going to be a lot about how you verify and acceptance test and these kind of parts. If you can build that confidence with your customer that you have a proven technology, even though you're fast, it's going to be a lot easier. Was it answering your question? Yeah.
There's another question for Mark. First of all, thank you for taking those questions. That's great. And I think has Mark Littrick. Hi, Mark. So great question. And yes, somehow our methodology, we are not fast enough in order to close the gap with all those advanced process nodes. So, and you mentioned standardization.
Yeah.
Of course, being sponsored by Accelera, we believe in having common standards, right, in order to have some progress made and tackle on the features, and not tackle with all the different standards. So what is your view of this, Petra?
I think it's a really good point by Mark, and standardization is something that really slows us down. So we must be a bit open about that. And I think we can, of course, speed up parts of it maybe, but since it's a lot about agreeing, different people agreeing, it's always going to take a little bit of time, which means that, but standardization is also a great enabler. It opens up the markets, it opens it up for new players, it will actually burst innovation, and a lot of good things are coming out of standardization. but you are going to be a bit slow in the standard layer. So you are going to keep that in mind, that this layer is going to run a bit slower. And then you can, take a risk in one of your faster layers then and say that we are gonna have this solution until the standardization is in place, or we're gonna guess, that we're gonna place a bet that this is what the standard is gonna look like, things like that. So that's risk taking. Then you're in risk management business, right? Which could be good sometimes, or you can use the time to test different things. But yes, it's really good just to be aware that we might get a bit out of sync when we are, working on parts that are standardized, because it will take longer.
Right. There's some discussion ongoing, on one point from Cedric on that point is not having the standardization. It would have many more downsides than delay due to standardizations. I think that's a fair point, right?
Yes.
And always, the finding the right balance. Yes, I've been to meetings where basically people said, okay, let's move forward, create the standard later, something.
Yeah, you could do that, and it will, save you some, or it will work for some time, and then you're gonna have to redo everything.
And I think some good points from Christian Macario coming in, a couple of needs from the semiconductor design. Need to be able to optimize the entire system architecture rather than optimizing the various building blocks. And this is slowing us down. You can't split the probability into smaller pieces.
Yes, and that is the other thing that will always slow us down is when you have to think end to end, the full custom. If you talk like customer journeys or a tech end to end, and as soon as you move up to that solution level, you will also be slower. So you have to be very careful with what you do at that layer. I mean, what do you do when you're at the full solution layer? It should be only what you need to do. So I think one trick that I use when I work in companies that have this, that build complex solutions, is that you start from the bottom, from the fastest layer, when you're the smallest, the smallest amount of people who can solve something. And then you're like, can we add value if we solve it here? No. Okay, then we have to go up one. Can we add value? Can we add? And then you so you always start from the smallest amount of people who can fix something, and then you will gonna have to go up the abstraction layer. And this solution layer, if you deliver solutions or an architecture at that level, you are delivering a huge value, because now you're delivering something complex, something that is hard to do, something. And then some parts of it will take a little bit longer, but that's also the value that you are delivering. So sometimes you just have to be patient, right? We are delivering value. We are a bit slow, but the complexity that we are managing, no one else do it.
Some more comments coming in and questions. So from Jacob, I think the question is how to explore the end-to-end without getting stuck in the details.
Yep. So, this Jacob, this 1959, right? Parkinson, he wrote this article about bike shedding. Have you heard that? That's a great expression, actually. And we always end up there, because he was in all these 1959, he was in all these committees about building nuclear power plants in England, I think. And he noticed that on these committee meetings, instead of discussing the nuclear power plant, we were discussing the bike shed, because no one understood the nuclear power plant. It was too difficult to understand. So we kept going into the details, because we can grasp the details, it's easy, we can understand it, So if we are a senior architect or a senior product manager or a senior something, it is our job, our role to lift the discussion, So we're gonna have to lift it one level if that's where we are, and discuss the architecture in the end to end. And it is gonna be difficult, and it is a complex discussion, but a few of us can actually do that. That's what we're paid for. So. But yeah, be aware of that, because it's so easy. There is even a law for it, right? That we kind of go into details. So think about that then, Jacob. Is this bike shedding? Let's talk about the nuclear power plant instead.
Right, and also to finish up the question from Christian, I think he was also saying, you know, that the need for agility and the need to be able to optimize the entire system architecture. How does this map to the speed layer? What is the recommendations?
So actually, when we talk about optimizing systems or configuration or tailorability at that level, we usually see it as there are like two pieces. We have kind of one logic or framework or thinking that is slow, like how we are setting the system, we are building the configuration tools. Maybe we have reference architectures or what we have. So we have something that is kind of where we have a lot of thinking, and maybe this is even our core. Like if you build airplanes, they are rather configurable actually. And this kind of framework for doing these configurations and testing them and validating, that's part of their core delivery. But then actually doing it, that's fast, right? So it's almost like there are two parts of this. One that is going to be slow, where you have to think a bit, especially like you're going to have rules saying that you can't configure it in this way, or these are not allowed configurations and things like that. That's going to take some time to build up. But then actually setting it is going to be fast, and hopefully also testing it is going to be fast. But I leave that to you guys
yes.
to make sure.
Thank you, Petra, and thanks for taking all the questions. Great questions, by the way. Thanks for asking those questions, and thanks, Petra, for answering it. And that been also, you know, fantastic keynote, yeah, and very inspirational. Let me share the screen. I've taken some pictures. I hope you can see it during your presentation. And I think, you know, that is where I believe, you know, we went to the end, right, where you were presenting. You know, we had been to our virtual world, you know, watching to you, and people asking questions to you. So I think that is a really nice combination of, you know, how to combine the remote world, the virtual world, and of course, looking forward to see you everybody next year in Munich live on stage, and having then, you know, also then I could give you the gingerbread, which is a custom at DVCon Europe, for giving thank you to our presenters and authors. I could not give it virtual, but really live to you. Thank you so much, Petra.
Thank you, Oliver. It was a great honor to be with you guys. And I wish you a great continuation of the conference.
Thank you so much. Thank you much. Yeah. Greetings to Sweden. Thanks, Petra. Bye-bye.
Bye.
All right, here's the program continues. Thanks for listening in. And yeah, next is coffee break, and I hope you can use opportunity going to the virtual world, chatting with our sponsors, exposition, and then continue on the tutorial side. Thank you. Bye-bye. This wraps up the session.